All right, welcome to lesson 7.5 for 5th grade. This is titled A Triangle Hierarchy. We're on pages 246, 247. Before we dive into the actual triangle hierarchy, we're going to talk about hierarchies. So a hierarchy is just basically a way to order or group certain subjects. In this case, my example has to do with students in our class. So in the hierarchies we'll be working with, we'll have a main category that is as basic as it can possibly be. And for us, the main category in my example is just students in our class. Literally everybody. Doesn't matter who you are, doesn't matter what you play, what you do, you are included in this top category. But the next category is called a subcategory. And that's where things get a little more specific. So our subcategory will be, in this example, students who play sports. Now, if you're someone who plays sports, you'll be in this category. If you don't play sports, you're not in this category. You'll be in a different subcategory called people who don't play sports. But either way, it's getting a little more specific. Now it's not everyone. Now it's only people who play sports. That leads us to our next subcategory. It's going to get even more specific, even more specialized. The third category is going to be students who play soccer. So now it's not just playing any sports, not good enough for this particular hierarchy. Now it's going to be only people who play soccer. And let's take it one step deeper. How about students who play goalie? So we went from including every student up top to suddenly now only those who play sports, now only those who play soccer, and then finally only those who play goalie. Now here's the cool thing about a hierarchy. Watch this. Do all goalies play soccer in this case? Yep. Does everyone that plays soccer play sports? Yeah, soccer's a sport. So if you play soccer, yeah, you play sports. And now in this case, if you are a student in our class who plays sports, are you a student in our class? Yeah, you bet. So you can actually end up working your way backward where if this is true, then that means this is true, and this is true. Does that make your brain hurt yet? I hope not, because let's get to the math part. Our main category today is triangles. It's literally a triangle hierarchy. So our top subject is just triangles. And triangles, of course, are any shape that has three sides. It can be any type. We don't have triangle cards, so I'm just going to freestyle a few triangles. Some weird looking ones. I think I just accidentally made a face. That's cool, I guess. So those are three examples of just triangles, anything with three sides. And now let's go to our subcategory. So this is our cat. I'm going to call it cat for short, for category. And now this is our subcat. And the first subcat today is going to be isosceles triangles. And we've talked about isosceles triangles. And if you're bugging out saying, oh my goodness, I do not remember, number one, how to spell it. And number two, what it means. Don't worry. That's what I'm here for. Isosceles triangles are triangles with at least two equal sides. And I'm going to emphasize at least, because it doesn't have to be exactly two. It just has to be at least two equal sides. And the protractors or rulers in your possession, I think most of us have protractors in my classroom. This is where they actually do double duty, where they're not just measuring angles, but you can use the ruler portion to make an example of an isosceles triangle. I'm going to use a 1-inch side, and since an isosceles triangle has at least two equal sides, I'm going to make this side 1 inch as well. And then all you have to do is close up that third side. And we symbolize equal sides in angles or triangles with just either single lines like this. See how they both have one line, or a double line in some cases. So an isosceles triangle is our first subcategory. And that's a triangle with at least two equal sides. And now, just like our student example, where we had multiple subcategories, we're going to go even deeper. So for students, we had students in your class, students who play sports, and then students who play soccer. In this case, we're going to go from triangles to isosceles triangles to our next category, and we're only doing 3 categories today. And our third one is going to be equilateral triangles. And the only difference with an equilateral triangles, or with an equilateral triangle, sorry, I was writing plural and saying singular, is now these are triangles where all 3 sides are equal. Let me catch up here, where all 3 sides are equal. And I'm a little worried about drawing one because I'm kind of in a tight space here, and with the fold of my book, I'll make sure it's on camera. You can tell I don't have a lot of breathing room. Maybe I'll try to make a 1/2 inch. If every side is a 1/2 inch, maybe we can pull that off. So 1/2 inch is right here. One side is a 1/2 inch. Here will be the bottom side, 1/2 inch. And then hopefully this works out. Almost. Trust me on this one for now, or just believe me. So an equilateral triangle will be a triangle that has 3 equal side lengths. And you can tell in the name, it kind of gives it away. Equilateral, they're all equal. But now let's look at the hierarchy, and here's the question that I'm going to ask you. I'm going to throw this back up front. Remember how a student who plays goalie was also a student who played soccer, because goalie is a position in soccer. All soccer players play sports because soccer is a sport. And all people who play sports in our classroom are literally in our classroom. So now let's look back at triangles and see if we have the same type of trick. I guess I'll ask with this first question here. Are all equilateral triangles isosceles triangles? Think about that one for a minute. Are all equilateral triangles also isosceles triangles? And if you said yes, you're correct. Because take a look at our definition for an isosceles triangle. Triangles with at least 2 equal sides. So that tells us, does an equilateral triangle have at least 2 equal sides? You bet. It's got 3 of them, guys. So that means he meets the 2-sided threshold. It beats it. Okay? If you have to be at least 5 feet tall and you're 5'5", does that work? You bet. It's the same type of thing. Equilateral doesn't only have 2, it has more than 2. So he definitely fits. All equilateral triangles are isosceles triangles. Cool. Just like all goalies play soccer in this case. All soccer goalies, that is. So let's go one step further. Are all isosceles triangles triangles? I mean, that's kind of, it's in the name, isn't it? So it seems like it works. All equilateral triangles are isosceles triangles as well. And all isosceles triangles are just straight up triangles. It works. Okay, so this is the groundwork for page 247. And let's take a look here. I don't know if I'm going to give away a lot, but we'll take a look at number 1. And it says name a category shown on the hierarchy, and then name a subcategory of that category. So we talked about how this is our main category here, but I'll throw this at you. Isosceles is a subcategory of triangles, but equilateral triangles becomes a subcategory of isosceles triangles. This sounds really confusing, but really anything below becomes a subcategory to that category. So in this case, isosceles is a subcategory to triangles, but it can be its own category for equilateral triangles. So really, even though it says category, you might be tempted to put just triangles, which you can. You could get away with starting with isosceles triangles if you wanted. Here I am writing something when I said I wouldn't. And then what you can do is look for a category beneath isosceles, and that would be the subcategory of an isosceles triangle, because we found out that equilateral triangles are a more specific type of isosceles triangle. Okay, so numbers 2 and 3, they're going to have you draw some examples of an isosceles and equilateral triangle. Remember, use this guy or a ruler if you have it. And then number 4 is going to ask you to fill out a few almost like if-then statements. It says in each statement below, replace the underlying category with a different category from the triangle hierarchy so that the new statement is still true. So number 4 says, here's the original statement. All triangles have 3 sides and 3 angles. That's true. Every single triangle has 3 sides and 3 angles, but they want you to replace this category, triangles in this case, with a different category that will still make the sentence true. So you could choose either isosceles, if that's true, do isosceles angles have 3 sides and 3 angles? Or you can maybe choose equilateral. Those are your 2 other possibilities. So which one of those, or maybe both of them, makes sense for this sentence? They have 3 sides and 3 angles. And after that, the questions will get a little more specific, but I think you guys can handle it. Okay, so that is the quick rundown on what a hierarchy is and what a triangle hierarchy is. I think that's all we've got. If you have any further questions, let me know. Email me, comment, dojo. Elsewise, I will see you for lesson 7-6.